Good morning. This is Greg Troutwine, editor and associate publisher, Offshore Engineer, and I welcome you to the Bosch Rexroth webinar discussing 5 easy ways to ruin your offshore equipment, lessons learned in hydraulic maintenance. Over the next 30 to 40 minutes, you will hear insights from Bosch Rexroth experts, followed by 15 to 20 minutes of questions and answers from the audience. We invite you to submit your written questions via the message board function, and we will do our best to answer all of your questions here live or via follow-up email. Without further ado, I would like to welcome Jaime Sabogel from Bosch Rexroth, who will serve as the facilitator on the presentations from the Bosch Rexroth team. Welcome, Jaime.
Good morning, everyone. Thanks for joining us. Many thanks to you, Greg, and Offshore Engineering team to host us on this platform. A few housekeeping notes before we get started. As you can see, to ensure we're taking appropriate safety measures, Royce, Will, Tom, and myself are calling in from separate locations to be with you here today. I want to mention as well that in the interest of saving time, we'll forego any lengthy personal introductions and trust that you can read our bios on the registration page or the Rexroth microsite. All of that said, my name is Jaime Sabogel, and the topic we are here to present is the 5 easy ways to ruin your offshore equipment. Our agenda is intentionally short. I'll briefly talk about our Rexroth organization as it pertains to the big Bosch umbrella and where we fit in that puzzle. We'll talk about where you might recognize Rexroth in offshore oil and gas from a project and component perspective. Then we'll get into the subjects that drew you here today. My colleague Will Cook will take you through the design phase, covering tribology and oil selection. My colleague Royce Gerngross will walk you through the maintenance side, focusing on what we are looking for to keep equipment running. Tom Schickel will then cover a real-life example, which is the lessons learned part of our title. And of course, then we'll open up for a Q&A, where we hope to have a great discussion with all of you. As Greg said, we'll field questions at the end, and as they come up, please feel free to type them in the chat window. As you may have gathered from the previous slide, we as Rexroth are part of the Bosch Group, which is a massive organization of roughly 400,000 associates. And what most people don't realize is that since 1964, Bosch's majority shareholder has been the Robert Bosch Foundation, making Bosch one of the largest global non-for-profit organizations. Without public shareholders, we are able to invest heavily in R&D, giving us the leading edge in not only technology development, but product quality. For reference, in 2019, of the 77 billion euro in sales revenue, we invested 348 million euro back into R&D alone. Bosch is organized into 4 sectors, and you're likely more familiar with our consumer goods sector, which consists of power tools and appliances, or our mobility sector, including spark plugs and windshield wipers. Rexroth altogether makes up the industrial sector, including our automation technology and, of course, hydraulics. This is a quick overview of how the industrial sector is organized, and I won't dive deep into any of these. I'll simply say that if you need anything to move, we can help you figure out the best technology, hydraulic or electric, and truly be a partner in application design, which is why our promise to the market is, we move, you win. From a market segment perspective, and of course why this audience is here today, this is how we fit into the offshore world. At this point, you get the idea, we are really keen on organizing ourselves. So you will see that within the offshore market, our 4 main segments are construction, wind installation, production, and exploration. Within each of these, you may recognize our systems or components in the following machines: drill string tensioning, drilling machines, rotary tables, winches, skidding and fixation, heave compensation, deck mating, cranes, jackup, ship-to-ship transfer, or dynamic positioning thrusters. Again, we offer complete systems or are simply components of a bigger system. Offshore aside, Bosch Rexroth considered service as the central link of all the market segments, which is one of the reasons we landed on this topic. Since there is a slowdown in the new build market, we have felt a shift towards service and maintenance from our users. So we thought this topic would be most relevant and interesting. I'll now pass you over to my colleague, Will Cook, who will cover the design phase and maintenance.
My name is Will Cook. I'll be covering the first two easy ways to ruin your offshore equipment. Believe it or not, maintenance begins during the design phase. Moving parts create friction, and friction can lead to wear, ending in premature failure if you ignore the tribology of the system and the components. And then, of course, subsequently choose the wrong fluid. So let's dive into tribology. Tribology is the study of friction, wear, lubrication, and a design of bearings in the science of interacting surfaces in relative motion. What you see here in the picture on the left is a seal configuration from one of our large offshore riser tension cylinders. The photos on the right are microscopic views of how a metal rod could look interacting with the seal material and the hydraulic fluid. I will talk you through a quick animation to help you understand this topic further. Key elements of a hydraulic cylinders are both the piston, the cylinder rod, and the shell. The rod moves in and out of the cylinder shell. There are two pressure chambers, one on the bottom side and one on the rod side. The cylinder head is where the rod leaves the shell. The piston moving inside the shell and the piston rod moving through the cylinder head are guided by guide strips. Hydraulic seal configurations make it possible to pressurize the cylinder chambers. A hydraulic pump forces fluid into the cylinder. This results in the rod moving out or retracting. During this movement, the piston rod and the interacting surfaces are in relative motion. This is when the tribological systems are activated. By definition, tribology is the science of mechanisms of friction, lubrication, wear, and of interacting surfaces in relative motion. In other words, interacting between surfaces results in friction and wear and can be optimized by the right lubrication. A Streeback curve displays the amount of friction between two lubricated surfaces during relative movement. Although the least of friction occurs in the hydrodynamic lubrication area, for hydraulic cylinders, the tribological system is most active in the boundary and mixed lubrication area. Because of this, all three elements of the tribological system will have to be considered when defining the optimal seal system configuration. As the rod moves out and the fluid in the pressure chamber is squeezed between the surface of the rod coating and seals, a thin lubrication film will result. Height and stability of this lubrication film determine the friction and wear inside the tribological system and are the utmost importance of the optimal functionality of the system. Higher viscosity of hydraulic fluid means a thicker lubrication film. As the stability and buildup of the lubrication film can be disturbed by abrasive particles, cleanliness of the fluid is also an important factor. When the rod is retracted, the lubrication film needs to be dragged back into the cylinder shell by the rod. To avoid leakage, dirt is blocked by a Bosch Rexroth design scraper lip while the lubrication film stays intact. The seal cross-section geometry also influences the film. The right seal face design increases the stability of the film. We received the cylinder back in our shop, and I want to highlight that in this condition, the cylinder was fully operational, even though it clearly has been put through a strenuous duty cycle. This can be attributed to the initial design and proper tribology setup. I will now move on to the second topic, oil selection. When designing a system, many conditions must be evaluated when selecting the right fluid. For example, having the wrong fluid with certain seal types can create chemical reactions resulting in a huge mess, or even worse, failure. So when selecting fluid, some of the criteria we evaluate are duty cycle, how the equipment will be operated, 24 hours or once a month, environment, is the component exposed to salty spray in a splash zone or sand in West Texas? Explosion classification, are there risk of explosive conditions from gases or chemicals? Type of technology, is the mover an axial piston pump, a radial piston motor, or a cylinder? Each of these have very different operating principles with different fluid requirements. Again, the key for a lasting system is evaluating all interacting components to ensure fluid compatibility. Is it also important to note that this logic can be applied in reverse for retrofits. If existing parameters are known, as well as the fluid already in use, Bosch Rexroth can help select the optimal setup for your component replacement. To be honest, fluid selection is a science in itself, and that alone can be a week-long seminar, but because of our limited time, we will only show you 2 examples of these factors and how we use them to evaluate fluids in one of our technologies, radial piston motors. The FZG test is a critical test that measures fluid lubrication and wear protection ability on a loaded set of gears. As shown on the left, gears are put through a progressive load cycle. They are weighed, tested, then inspected for damage, reweighed, and put through the next load test until failure. According to common fluid standards, FZG should be at a fail stage 10 minimum. And to retouch on the type of technology comments from the previous slide, the radial piston motors have a higher fail stage requirement of 11. Failure to consider this factor can result in catastrophic failure to these types of motors. Another test that we use to evaluate fluids for radial piston motors is the KRL, taper roller bearing test, that measures the mechanical shear stability of fluids with polymer additives and synthetics. The bearing pictured on the right is used to shear the oil and measure permanent drop of viscosity as a result. This test is very important to evaluate manufacturer data sheets against dynamic properties. For example, if you have a VI improved oil, VI stands for viscosity index, it is possible that the polymers are prone to shearing when loaded. And when that happens, the actual viscosity of your fluid can be much lower than the advertised viscosity. Like I said at the start, this is all a science, and we have a team ready to help you make the right fluid choice. My colleague Royce will now dive into the maintenance topics. Royce.
Good morning, my name is Royce Gerngross, and I will cover the last 3 ways to ruin your offshore equipment. Number 3 is typically the most common maintenance task, and it's quite simple. So in this section, I will discuss the whys of fluid cleanliness rather than just make a recommended service interval for element changes. Ultimately, the interval can be influenced by many factors like environment and duty cycle anyways. So there's no simple answer to how often to change your filters. A hydraulic system can be compared quite often to the cardiovascular system in the human body. It has a pump, it has arteries and veins, similar to piping and hoses. It has white blood cells, which could be similar to an additive package, muscles, which can be considered our actuators, liver and kidneys, our filters, and so on. It also performs in our body a very similar function. In our body, it transports energy in the form of nutrients to the actuators, which transfer it into energy for our muscles to act as actuators. It also performs a similar function in that it brings waste from those cells back to the filters. It's very similar to a hydraulic system, which is designed to transport energy from a prime mover to an actuator. And similarly, the fluid in a hydraulic system is intended to remove waste heat from the system. And it's also there to perform lubrication. In both systems, the fluid chemical makeup is very critical, and how you maintain that chemical makeup can prove to ultimately end you in a catastrophic failure, or if taken well care of, will prove to extend the life of the components in both systems. The first thing we talk about in maintaining the fluid is oil cleanliness, and there are several types of contaminants that we talk about when we want to keep our oil clean. The first are gaseous type components, and primarily we talk about air. Too much air in the system, too much dissolved air can cause fluid oxidation, and it can also change the viscosity of the fluid that you've put in the system. If the air gets to an extreme point, it can cause cavitation-like issues, which will result in desealing of the fluid. The second type of contaminant we talk about are liquids such as water. When water is dissolved into the fluid, it also changes the viscosity. If so much water enters the system that it's no longer dissolved in the fluid, you begin to create corrosion, which creates rust, which is one of the most damaging type of solid particles. Another type of liquid contamination is other hydraulic fluids in the system. When they are not compatible with the current hydraulic fluid in the system, they can break down your additives and change the rated performance of the chosen fluid. Solids are there are several different types of solid particles, each of which can create different levels of friction and wear. They ultimately can produce more solids of the most damaging type. Oil cleanliness is all about minimizing the content of these contaminants, keeping them in acceptable ranges for the components in your system. It is impossible to run a hydraulic system and not have contaminants enter the system at some point. This is the point of a properly sized and properly maintained oil filtration and water separation system. Don't filter your oil if you want to destroy your hydraulic system. The fourth way to ruin your hydraulic system is to assume running hot is part of daily operation. During warm summer months, with reasonable certainty, machine temperatures will elevate. This is especially true if you're using air-to-oil heat exchangers. Focusing on the proper temperature range will prevent downtime, as heat generation is a leading indicator of a failing part. Knowing how to recognize the difference between normal temperature changes and those caused by a failing component is the difference between reactive and preventive maintenance. Viscosity, the resistance of a fluid, liquid, or gas to a change in shape of movement of neighboring portions relative to one another. When a fluid is more viscous, it tends to resist movement more. It's closer to a solid than a gas. Why are we talking about viscosity when the point is temperature? The viscosity of the oil used in a system is extremely important to the film thickness and lubrication, and its viscosity is related to temperature. Two ratings that we discuss relative to viscosity are the viscosity grade and the viscosity index. The viscosity grade is specifically the viscosity measurement in centistokes at 40 degrees Celsius. From the graph, you can see that a viscosity grade 68 is 68 centistokes at 40 degrees Celsius, and viscosity grade 100 is 100 centistokes at 40 degrees Celsius. From the graph, you can also see the slope of the line of each fluid relative to temperature. This slope indicates a fluid's susceptibility to change in viscosity with an increase or decrease in temperature, and it is referred to as the viscosity index. Using these values, you can choose a correct fluid and temperature range that is optimized for all components in a given system to perform a long life. As an example to discuss how the viscosity affects system performance, we will look at the internal piston of a radial piston motor. The principle of lubrication is dependent on film thickness, which is directly dependent on the viscosity of the fluid, and viscosity again is dependent on temperature. In a radial piston motor, the hydraulic pressure creates an axial force which forces the cam roller down the stationary cam. This rolling action creates a tangential force in the rotating body of the motor, translating into torque at the output shaft. Thus, the motor's purpose to convert hydraulic energy into rotational energy. This action creates friction at the cam surface between the roller and the piston, and between the piston and the piston cavity in the rotating section. Each body has a predetermined roughness for which a certain viscosity of fluid will keep the film thickness sufficient to minimize the friction and avoid the surfaces from grinding against one another. This animation is an example of one of our technologies, Hagelin's hydraulic drives. With all the moving parts, viscosity is important to maintain lubrication and allow the fluid to flow without excessive efficiency losses. What is lubrication? It is the process of separating two surfaces enough to avoid the surface structure, referred to previously as roughness, of the two parts from binding and wearing on each other. If the oil is too thin or not viscous enough, the surfaces will contact and grind, creating heat, raising oil temperature, which lowers the viscosity. This is a runaway problem, as more heat creates less viscosity, and it creates more heat, and so on. If the oil is too thick, it doesn't flow, causing problems like cavitation or, at a minimum, very low efficiencies in the system, thus hurting the power transmission function of the entire hydraulic system. As Jaime noted, Bosch is on the leading edge of technology. So for the fifth way, I will cover the most basic of health monitoring systems and end with the most advanced. We've already discussed the importance of filtration, but how do you know for sure it is working? Part of condition monitoring is analyzing the oil on a regular basis to understand the health of the hydraulic fluid. Contaminants can be built in. Common types are metal swarf, paint residue, weld slag. They can come from external sources, paint chips, rust, dust, dirt, addition of oil, etc. Or they can be self-generated through the failure of a component. Oil sampling and analysis helps to build a database of health of the hydraulic oil so we can see trends over time and note any unusually elevated results. The image to the right shows an example of different ISO cleanliness levels and the contamination allowed in each level. Sampling should be rated per NAS or ISO scales and should always be maintained within recommended levels for the particular components in your system. Regular oil sampling is a must. For the next level, there are things such as online particle sensors, moisture sensors, and air sensors, which all exist, but they are not a replacement for regular oil sampling, rather an addition. These devices are complementary to a great oil sampling program. For instance, the sensor could trigger you to take a sample sooner than you normally would. These sensors sitting in the middle are also part of the next advanced solution with trending and online analysis to predict a coming failure. So an even more advanced system is full online analysis provided by Bosch Rexroth Odin platform. The user has the ability to log into a portal and check on the quick health index of their system. Further, the user has the ability to build custom reports based on inputs from various sensors. They also can graph trends over time, looking for changes, and Odin can give a very early indication of fluid degradation or failures from the bearing vibrations. Coupling Odin with the correct sensors, a regular sampling program, allows Odin to predict not only that there is a pending problem, but exactly what the problem is and how long before it becomes a major breakdown. This is the difference between preventive and predictive maintenance. And now my colleague Tom Schickel will close out the presentation.
Hello, I'm Tom Schickel. Ahead of our Q&A session, I want to go through a quick real-world example and then offer a quick summary. So ignore the factors my colleagues covered, and the pictures above are what you will get. This example showcases what can happen when multiple factors are ignored. The initial failure of this winch motor showcases what can happen, occurred because the drive was overheated. The oil was too thin and the metal particles were created from fluid breakdown. So the oil was changed and a new motor was then mounted on, but the oil, upon being changed, was never flushed through, and there was some remaining residual contamination left in the piping and some of the other components within the system. So upon putting on the brand new motor, and again having recontaminated fluid, it was only a matter of a few minutes before the oil again began to diesel, particulate flushing through the system, and again you had another catastrophic failure. So again, just to highlight some of the importance of having a good clean oil, it's always very important to start with, I recommend a brand new oil base. So and a lot of times we found some OEMs that have complained on dieseling oils, and that's been the result sometimes of them trying to cut corners and using some older reconditioned oil stock. And the problem there is it's a little more challenging to maintain the oil preservative packages. And if that preservative package were to drop off very quickly, the oil will start to increase in acid number, begin dieseling, oxidation, and again, you immediately start attacking your components, and you'll see it changing color in a matter of hours, and then you'll start having the components start to break down. So again, to cover the 5 easy ways to keep your offshore equipment running. One is the tribology. Start with solid design and with the right components. And number 2 is going to be your fluid selection. Ensure all conditions and the technology are considered when selecting the fluid. Make sure the hoses, seals, accumulator bladders, even the metallurgy of the reservoir are all compatible with the fluid. 3, fluid cleanliness. Keep your oil clean. There are many moving parts. Now again, you're going to want to stick to around NAS class 9, which is about an ISO 2018-14. And then depending on what the components are, if you have proportional valves, servo valves, you're going to want to be even cleaner, getting down to like a NAS class 7 or 6. And then condition monitoring. Minimally sample your oil and consider continual monitoring. So make sure you're paying good attention to your indicators, and if you have a computer-based condition monitoring, even better. But always keep track of your trends. If you're starting to see your oil change and your acid numbers trending and accelerating and being more challenging, you're going to need to start checking and sampling more frequently to stay on top of it. All right, and so before we go to Q&A, I just want to leave you with a screenshot here to show you where our locations are for our main service locations. So in Bethlehem, Pennsylvania, for the Rexroth, and we have our service facility in Houston, which we do the large hydraulic cylinders repairs, as well as our large axial piston units and the Haglunds, and then also our Haglunds centralized service center in Grove City, Ohio. With that, I'll turn it over for our Q&A session with Greg.
Okay. Well, thank you, Will, Royce, Tom, and Jaime for these insightful presentations on hydraulic maintenance. I'll ask all of my colleagues to turn on their cameras now, and we'll have a Q&A session. We're going to open the floor to the audience. You can use the Q&A function or the chat function. We have approximately 15 minutes, 15 to 25 minutes actually, and we've received quite a few questions already, but I invite you to submit your questions via the text board and function through the final as we ask the questions. First one, and I believe this is for Royce, but I'll let you gentlemen decide. Why are only a side stream filtered in larger hydraulic systems?
Sorry, repeat that.
Yes, that would be why are only a side stream filtered in larger hydraulic systems?
Oh, a kidney loop versus filtering all the return oil. Typically, that choice is made when there can be several reasons. If a system has hydraulic shock in the return line, putting a filter there will ultimately destroy the filter and create contaminants versus getting them out. And so you would do a kidney loop. It could be that the flows are so massive on the return line that it's not practical to filter 100% of the oil. Things like that.
Excellent. Royce, you're popular. This one's for you as well. Is there a recommended general viscosity range for all hydraulic systems?
Some people with lots of experience will say yes, but that's primarily because they already have done this step so many times. But the correct way, if you don't know the viscosity of all the components, the viscosity requirements of all the components, is to create a fluid definition document where you list out each component in the system, its optimal and acceptable viscosity ranges, and then you list out the temperatures at which you expect to have to run the system. And then you have to find a fluid that can maintain a viscosity at those temperatures that works for all the components in the system. So depending, if you already know all your components, then you might know a viscosity range that's going to work. But then if you're applying it in a place where it's going to run hotter or colder, then you might want to take another look at which fluid, even though you've always used a particular one all the time.
Excellent. Thank you very much. Again, I'll let you gentlemen choose who answers this one. It's on humidity content. On humidity content, what relative humidity do you use on lubricant in the hydraulic motors?
Yeah, I guess I can kind of take that one. I don't really know how to answer a humidity level, so if one of my other colleagues has a better answer than this, please weigh in. But really, you want to have no humidity at all. So we have solutions that have desiccant humidity filtrations that end up going on your reservoir that pull humidity out of your system, and ultimately you want to keep water content as close to absolute zero as you can in any hydraulic system.
Excellent.
Royce, Tom, Will, any contributions to that on humidity? But
yeah, there are some recommended levels that are, let's say, can be accepted in dissolved water in the fluid. I don't have them off the top of my head, but we can give some of that information from our filtration guys. But again, that depends on the component. You have to ask the component manufacturer if there's anything special.
Tom, I believe you're on mute.
Sorry.
No, okay.
Yeah, so depending on the fluid too. So something like a phosphate ester is going to be less tolerant of moisture than a mineral oil. So in those cases, yeah, you want to be using a desiccant breather and keeping the water contents down. And say for a mineral oil, you want to be about 1,000 parts per million or less. And then when you start getting really high water contents, you actually start seeing it entrained in the oil. And when you start seeing through the sight glass that you've got milky hydraulic oil, definitely shut down and take remediation efforts.
Awesome. All right, Tom, now that we have you back off of mute, I think this next one would be best answered by you. Is oil from the drum, direct from the manufacturer, clean enough for my hydraulic system?
Okay, so normally we'd say no. So new oil, bulk oil really needs to be filtrated before putting into your system to be commissioned. So we didn't touch too much on what those cleanliness levels are, but really an NAS class 9, which kind of translates to an ISO level 20, 1814, 1815 type level, is already going to be the top end of acceptable cleanliness. As far as any more dirty than that, you're really going to violate a lot of manufacturers' warranties. So you really want to use a filtration cart, something to transfer that oil out of the drum or the tote into your hydraulic system. And even, Royce had mentioned, some of the benefits of a kidney loop. Even after you have that fluid in there, if you can go ahead and run the kidney loop for a few hours before starting up your whole system, you'll even do some additional conditioning to get that fluid extra clean.
I want to add too to Tom's points that all of our power units come with a fill port that normally is through a filter. So do not open the reservoir to fill it with oil. You use the filter and the fill port that we designed in.
Yeah. Now, sometimes people like to just take the breather off for the quick and easy and just pour the oil in there, but it's really great to filter it through a filter on the way in too, like Jaime just suggested.
Excellent. Thank you. This is a long one, so give me a moment. One issue I see with offshore vessel equipment, cranes and pipe lay equipment, is the aging of hydraulic oil. In most cases, we hear reports of darkening of fluid and burn smell. What is your advice for a system that encounters this? Do you think a ruler test and MPC is the best way to monitor?
I think, yeah, I can try to take that, but I think as you start seeing that the dieseling, and that's when the sure sign tells that the oil is aging or oxidizing and dieseling, you're changing the color, but not only that, but you're starting to pick up a bit of a more putrid smell to the oil too. And you have to be careful, because sometimes when you get that dieseling, if you don't know exactly what is causing that, it doesn't necessarily trigger your contamination levels to say, hey, you've got an NAS 9 or 10. Sometimes you can form really fine 1 and sub-micron particles that are just real soft, globular, but they're very adhesive in nature. And what can happen there is they start clogging all the fine lubricating ports within your hydraulic system. So once those ports are clogged, say like on the lubrication piston holes on an axial piston pump slipper shoe, you'll start losing that lubricity film and start having catastrophic failure. So I would say do frequent sampling, but you really have to get to the problem of what it is. Is the preservative package falling out? Do you have a hot spot in your system? What is the cause? And so again, it's just trending. So if you can make sure you're changing out your filters and keeping an eye on the health of the fluid. So as you come back and you're seeing that it's healthy after checking on a weekly basis, you can go to a monthly basis and so on. But I think depending on what you're experiencing is going to be depending on what your solution needs to be.
Thank you very much, Tom. Next one, what conditions do you recommend an oil over a grease system?
Recommend what? An oil over a grease system?
Correct.
For lubricating.
That was the extent of the question.
It sounds like he's talking about a system that would lubricate. I would say that's outside the scope of what we provide. We don't provide lubrication systems.
Okay. Awesome.
Yeah, maybe if we could just get a little more detail, if that question submitter could just expand a little bit on the equipment or what he's using there, we can probably come back with a more definitive answer there.
Awesome. Thank you. We'll suggest that. I think this one would probably be for Will. It's on condition of fluids. How often should you have the condition of your fluids checked?
Well, I think we all kind of touched on this a little bit, and it really depends on the environment that your system is in and the duty cycle of it. So, it's very dependent on those factors. We did talk about that in some of the slides I went over, and Tom talked about that just a little bit ago at the end, and just probably the previous 2 questions. But I would say for environmentally friendly fluids, at a minimum monthly, and then for a mineral oil base, probably quarterly at a minimum. Now, if you're seeing degradation in your product, it's better to check it sooner. If you have some kind of condition monitoring system and it's giving you alerts, definitely check it sooner.
Excellent. The next one is in regards to service. What kind and size of cylinders can you handle in your service workshops? And do you work on just your own equipment or other equipment as well?
I'll take that one as well. So what size? We can handle anything up to 120-foot stroke. We have 40-ton crane capacity in our Houston facility. We do work on our own products and others as well. It depends on the system that we're working with. And we need to know, if it's not our own product that we designed, we need to know as much technical information as possible to do a thorough job of inspecting and providing reporting to the customer.
Very good. Scrolling through my various screens here. Since the offshore oil and gas downturn started 6 years ago, have you seen a downturn in hydraulic fluid maintenance and care overall?
I think I'll take this one, guys. I think it's actually gotten a little bit better, I think, because as we all know, we're not having a lot of new builds and new build requests. So I think the shift has gone from some of the budget that was being put towards new equipment has shifted a little bit towards the maintenance side. So in general, I think for Rexroth, we've been doing quite good with the maintenance and service side of our business. Yeah, and that's partly due to what the question is asking is, you know, people are paying closer attention to what it takes to keep their equipment running.
Okay, thank you, Jaime. One question here, excuse me for the moment. I don't know if this is I don't know who would get this, but what are your experiences with non-ester based biodegradable fluids like HEPR biotypes?
Yeah, I know we have used them, and of course that's a very common question that we have offshore. It depends on the type of technology, and of course when you get into that type of fluid, you have to pay a lot closer attention, so to speak, to make sure you're selecting the right one. So I guess the short answer to a very complicated question is it is possible, but you have to really pay attention and certainly consult with one of us, of course, if it's for a Rexroth product, to make sure that we're selecting the right one together.
Excellent, thank you, Jaime. Regarding the online monitoring systems, as I understand it, this being the questioner, of course, as I understand it, the information is sent to Bosch and then relayed back to the customer. How often does the customer get a report?
The Odin system that I talked about is actually a customer account created, and they have a dashboard. You can log on and watch it 24/7. It's live feed to Rexroth. The reason it's sent to Rexroth is for the algorithms to predict failures to be able to run on servers in-house. And then the dashboard is available for you to log into and even create, you know, if you want to look at, of course, the sensors have to be fed into Odin, but if they're there, you can pick the sensors and look at trends of your choosing on that dashboard.
Okay. Looking still at that Odin system, does the Odin integrate with other monitoring systems on the platform or vessel, and can it be monitored shoreside as well?
I would have to get with the Odin specialist that's getting a little detailed for what I know about Odin. I believe anywhere you can get an internet access point, you can look into it. As far as integration with other monitoring platforms, I think that depends on the platform, the connection type, but I'm sure something can be done, but that's getting a little more custom.
Excellent. Thank you, Royce. What is your opinion, or do you have an opinion, on oil distributing outfits that offer lower cost lubricants? What they do is blend components and claim to be the equivalent of brand lubricants?
Because that kind of goes to what Tom was saying about blended fluids. Shickley, you want to take this one, or?
Yeah, no, I just go back and reiterate, be careful. Go back, research. You can always check with, depending the components manufacturers on recommendations. Many of them have reference lists. But yeah, definitely go through and double check as far as the quality of the preservative packages, and then see the history and references there. So that's what I would recommend. But again, it's getting back to if someone's using reconditioned old oil, you want to make sure you're using new quality stock.
Yeah. And I think maybe we should reiterate, because Rexroth will never choose his fluids. We try to help, let's say, recommend fluids. But ultimately, the responsibility of warranty that the fluid is acceptable lies within the fluid provider. So double check that whoever you're buying the fluid from is covering the warranty of your products if it happens to not meet the specifications provided by the manufacturer.
Excellent. There's a couple more, and we still encourage you to send them in if you have them. For your products, do you have any requirements to lubricant on dissolved gases? And they're talking about, I guess, oxygen and corrosion.
Oh, dissolved oxygen or dissolved air in the oil. Tom, do you know a particular number that we normally recommend? I don't know off the top of my head.
Yeah, it's not a frequent one we get. Maybe that's another one too, if we can get a little more elaboration on exactly what the nature of the question is. But for the most part, if you have entrained air in, then basically you will start having other issues in your system, dieseling, cavitation, those sorts of things, and basically you'll want to de-aerate those systems. But even I think 1/10 of a percentage of air in your system, really affects what I think it's almost 0.7% of the volume of your fluid. So that, and then if you start getting into particulars of oxygen, pure oxygen condensing in the system, that makes for a dangerous situation too, when you start adding compression and the other flash points of depending what the fluid is there. So maybe a little more background on the nature of the question being asked there, and we can try to get a more comprehensive answer back.
Right.
Okay. And just as a side as well, because I've gotten several requests if the presentations will be available. There will be information available to all registrants and all attendees afterwards. And of course, the Bosch Rexroth experts will be at your disposal to answer the questions that you have. Couple more. What is your cleanliness requirements for your hydraulics motor typically?
Yeah, I saw that one in the chat, so I pulled up the engineering manual real quick, so I didn't speak incorrectly. This is assuming we're talking about the Hageland's radial piston. Maybe Tom or Royce can talk about the axial, but the B10 is 75, or particles greater than 10 micrometers are filtered out is the minimum requirement.
Excellent.
Yeah, we usually try to say, try to be at a NAS class 8 or better for some of our Rexroth axial piston pumps and motors, and many manufacturers too, from our external gear pumps and motors are a little bit more considerate. They can last a little longer, so NAS class 9 or better usually for external gear.
Okay. Sorry about that, gentlemen. The modern world, I'm just clicking my multiple screens to make sure we have everything covered. It certainly looks like you've given a great presentation and answered all the questions as they've come in. Oh, hold on 2 seconds. One more question. And don't apologize for asking the second question. we encourage questions. Can you tell me if hydraulic cylinders kept in long-term storage are better to be stored vertically or horizontally, or does it matter? My concern is the flattening of the piston seal.
So I'll take that one. It's always better to store your cylinders vertically. Now, whether you can do that or not is a very big challenge. If you can't, you can rotate the cylinders over a period of time, and you can exercise the seals. You don't have to do it very much. You could go out like maybe a meter or so and retract the piston rod a meter. But that will keep your seals lubricated, and it will prevent flattening if you exercise them and rotate them if you cannot store them vertically.
Excellent. I just see one more, and why add accumulators in the tank line of hot oil shuttle valve in winch applications?
I can take that one. And I would have to look at the schematic to be for sure I'm correct, but correctly understanding the question. But my presumption here is in this particular circuit, the concern is to make absolutely sure the minimum tank pressure on a hydraulic motor on a winch when the brake is released is maintained. And the reason for this is once the brake is released, that winch will begin to leak down, and oil must be fed back into the low pressure side of the motor for it to be able to continue to hold the load. Otherwise, the system will rotate a few rotations and it will cavitate and the load will fall, creating a really dangerous situation. So my assumption here is someone added an accumulator to make sure it doesn't drain all the oil out of the tank line whenever you're just holding a load and not moving up.
Thank you very much, Royce.
Mm-hmm.
Okay, gentlemen, again, I appreciate your presentations. To the audience members, we obviously appreciate your participation and your questions as well. Jaime, unless you had something further to add or you're seeing something that I'm not, I believe our work here is done.
Yeah, I agree. Thank you very much for having us. Yeah, really enjoyed the discussion. Reach out to us if you have any further questions.
All right, gentlemen, and everyone in the audience, have a great day.
Thank you.
Thank you. Bye-bye.
All right,
Yep,
bye.
bye-bye.
Thank you.